Good morning. What up? Everyone say hello to
Anise.
Bless you. Okay. So today's we only have 4 objectives. We're going to use right angle trig. You will have to learn these, but I think you already know what these guys are. Yeah, this should be what? How many degrees here? It's a 30 degree, right? Because number 6. That's going to be a 45 degree. That's a 60 degree.
Oh, yeah.
You picked that up already, right? Okay, I'll show you where those 2 special triangles came from. My version of it, which makes sense. And then we'll do some complement stuff. You guys remember what complements are, right? 2 numbers that add up to 90. 2 numbers that add up to 180 are supplements. Those are your vitamins. All right, cool. Let's move on. So, this is just definitions. Sine, cosine, tangent. Sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Hopefully, you should know these already. If you don't, work on those. Okay, if you want a SOHCAHTOA, or you know the other one that we don't say.
Can you explain that to me? Because I really don't like.
What, SOHCAHTOA?
No, I don't understand what you're talking about.
Here. Oops. So, ka, toa. I'll tell you later. Because it's like a little rhyme or something. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, now the other ones you still need to know. That's on the next slide. It's these guys, right? The cosecant, secant, cotangent. And those are simply reciprocals, literally. You flip them.
Oh, yeah.
You flip them.
I forgot.
So, let me... Hypotenuse. I love the way that sounds too. Hypotenuse. Hypotenuse. So for sine, it's cosecant, and that's simply hypotenuse over opposite. For secant, that's going to be hypotenuse over the adjacent. And for cotangent, that's going to be adjacent over the opposite. So you need to know those. Now, realistically, I only memorized the first 3, and then which one is supposed to be their reciprocal. And I think I mentioned how I remember them, right?
Yeah.
Cotangent, reciprocal, tangent. Secant almost looks like cosine backwards, and then the leftover one belongs to sine.
Wait, where did you get O?
O is opposite. O is opposite. Yeah, it's not a 0. Okay?
Yeah.
Let me clear my throat. Okay. Ben on the right, and that's Big Chummas. Have you seen it? There's a meme going around. It's Bugs Bunny. Bugs Bunny. It's Bugs Bunny, but like he stretches him out and he's like,
Bugs Bunny?
yeah.
Bugs Bunny.
That's what I said.
I thought you said Bugs. Like, never mind. What?
Big Chummas. Chummas.
Why does it look like that?
It's because they stretch the picture, so he looks all chubby. All right, I'm gonna move on. Okay, so we'll be working with some triangles like some triangles like and they're gonna ask us to find all 6 trig functions, right? Now, if I know 2 sides of a right triangle, I should be able to find the third using. Yes, absolutely. The hippopotamus. I can use Pythagoras theorem, a squared b squared equals c squared, where c is the longest side, the hypotenuse. In this case, I've got a 3 and a 4. So I've got 3 squared plus 4 squared equals c squared. So I've got 9 plus 16 is c squared. 25 is c squared. So once I take the square root of both, I find that C is 5. Now, just a heads up, and you probably already knew this. If you do see that the legs of a right triangle are 3 and 4, that's a special type of triangle. It's called 3, 4, 5. And it will always be in those proportions. So if I have a 6, 8 for 2 legs, then the other leg would be a 10. So 3, 4, 3, 4, 5 triangle, and whatever proportions there are. There are more Pythagorean triples that way. Google them. But there's more proportions that always work out. Besides the 3, 4, 5. What's up?
I don't want to interrupt your lesson, but can you do a problem? It's from geometry.
Sure. What is it?
So, this is an A, and this is 29, this is 35.
Please have your now that you actually say that, please have your problem by Friday. The circle in the trapezoid, in the isosceles trapezoid. We'll do that later. Why? Did that come up on your homework?
No.
Actually, I think we're doing that today.
Okay.
So let's pause, and if we don't get to that, then we'll do it. Okay? Don't erase it. But I think we're actually doing that today. That exact, not the exact problem, but that same idea. Okay? So are you guys okay with this problem? Everyone okay with C being 5?
Yes.
So once we know that it's 5, like there, then I can say, okay, the sine in this case, sine of theta, opposite over hypotenuse at 3/5, which means that the cosecant is 5/3. After cosine of theta, that means adjacent over hypotenuse, so 4/5. That means that the secant is 5/4. And then I want tangent of theta, which means that's opposite over adjacent, so 3/4, which means that cotangent is 4/3, and there's all 6 of them, without ever having to know what theta was.
Yeah.
Okay? So we could find that. We could find theta, and that's kind of the idea of what you're doing there. But we'll get to it in a minute, I think. Well, not a minute, but a few minutes. Okay? You guys cool with that? All right. Let me. Anybody writing? Okay. Yes. Any list? I'm excited because the trig is so fun. Can't wait to do all these graphing and.
Well, Lily, you like to graph?
Okay. Sometimes. This is a square. Please pretend it's a perfect square. I know it's not. Pretend. If this was a square, what do I know some properties about this? All sides are the same. So let's call all the sides 1 unit, okay? So this will be a unit square. Cool?
Sure.
And then what else do I know about this? All the angles are 90 degrees, correct? So that's 90, 90, 90, 90. Now, I don't want the whole square. I don't want the whole square. I only want half of it. So I'm going to cut it from diagonal to diagonal, and then I'm going to get rid of this piece of it. Gone. Okay? Go with that? So that's changed some stuff, hasn't it?
Correct.
What is my measure for angle A now?
45.
It's 45, isn't it? And what's angle B? That's also 45. And what's this long piece? What's that long piece?
I bought the radical 2.
It's square root of 2. Now, if you don't know where it came from, I just did Pythagorean theorem again. So 1 squared plus 1 squared equals c squared. That's 1 plus 1 equals c squared. 2 equals c squared, square root of both sides. Therefore, c is radical 2. And guess what? That's where 45, 45, 90 comes from. Okay? What's really nice about this is that I can generalize this idea of the 45, 45, 90 as, I'll write it, I'll draw another one here. I can generalize a 45, 45, 90, 45 as x, x radical 2. Now, does everyone understand the idea of generalizing it? That means that I can make it bigger, or I can make it smaller, and they would all change by that proportion. So let's say I had a 45, 45, 90, where one of the legs, so I'm telling you this is a 45, 45, 90, and I'll do it by doing this, right? telling you that these are the same, and I told you this, you could find the other two sides without. Oh, sorry, I didn't want to put 1. Let's do 5. Okay, so now I know what all the other sides are because of the properties of this specific triangle. If this leg is 5, what's the length of this leg? That's also 5, and the hypotenuse would be 5 radical 2. Cool? I can make it 10 times bigger, 12 times bigger, and all those x's would become the ratio of what the legs are. Pretty cool? Cool.
Can I ask you a quick question? It's kind of off topic, but when you're trying like the triangle on the circle, so like that, but do you always come back down to the
Yeah,
the
yes,
X or
you
the
do.
Y?
So here's your question. What you really want to graph first is the ray that produces your angle, right? Your terminal side. So if I did a 35-degree angle, it would put me here, correct? So I draw that, and then yes, I always come down, back down to X.
So if you were on any other quadrant, you always come back
If
down.
I end up in quadrant 2, where my angle terminates here, I would come back down to X. And if my angle were to terminate down here, I would come back to X. Okay? And if my angle were terminating quadrant 4, whoops, I didn't mean to do that at all. If I were to terminate here, then I would also come back to X. Okay? And whatever the difference is for the small angle is what I would use. Okay? Which would be a, what's the word I want to use? I don't know what the word is I want to use. But anyways, are we okay with that 45, 45, 90 and its properties? Okay.
Wait, can you slow down first?
How about I do that? Yeah? Okay. So that, Greg, you'll just have to remember and memorize where those things come from and what the ratios are. And if you already have them down, that's even better. Okay? Thanks for putting your cell phone away. I can change the slide now? Okay. Let's talk about another regular image. This regular image is a regular triangle. What do I know about a regular triangle? Again, all sides are the same.
All angles equal. All sides.
All angles are how much?
Wait.
The degree equal one.
Yeah.
They're all 60.
But they.
Well, they should always, any triangle, all angles should add up to 180. But if this is a regular triangle, all angles are 60. For this one, I'm not going to make the sides 1. I'm going to make them 2. Cool? So I'm going to make them 2, 2, 2. I can do that, right? So legit? Okay. We're going to cut this one in half as well. I'm going to go right down the middle, like this.
Scaly, isosceles.
Okay?
Right triangle.
So when I do that, I've created a perpendicular line, haven't I? Which means that this angle is 90. This side is useless because I don't want it anymore. Okay? But that's done some stuff to my angles as well, right? This 60 up there is no longer 60. You got cut in half.
30.
Now it's a 30. So that's 30 degrees. I should not do that. That looks horrible. So now this is 30. And this base used to be 2 units long, right? But if I cut it in half, now it is 1. And there's your 30, 60, 90. I got 1, 2. And if you use Pythagorean's theorem, what's the other side? It's going to be radical 3. Okay? Now here's what I had you to remember where the 1 is. I just remember that opposite 30 is 1. Because they all used to be 60. That got cut in half. So the side opposite also got cut in half. Okay? This triangle can also be generalized. You can make it bigger. You can make it smaller. And it would go x, 2x,
Can you put that into Pythagorean theorem?
x radical 3. This part for the radical 3?
Yeah.
Definitely. So let's call this, for now, little a. So I'm going to go 1 squared plus a squared equals 2 squared. That would give me 1 plus a squared equals 4. Take 1 away to both sides. A squared is equal to 3. And then finally I take the square root of that, which gives me radical 3. And there's your work for that, okay? And then the generalization is right over on the right.
How do you know where each one goes? Like where each like variable goes?
So if you remember it looked like originally, it was all 60 and it was all, okay, the top one got cut in half, right? Which produced a 30. Opposite to that should be the side that got cut in half as well. So that's a 1. Well, it doesn't matter. You could call it A however you want. But what you really do need to remember is that opposite 30 is the 1, and the opposite 60 is the radical 3. I have another little thing that I remember. I don't know if you guys want to hear that. I'll tell you, and if you like it, then you use it. If you don't like it, then throw it away, okay? Everybody knows how to count, right? Up to 3? Okay?
1, 2, 3.
Okay, the only thing is that this requires for you to know a little bit, right? So, let me draw my 2 real quick. Here is a 45, 45, 90. And I know that in a 45, 45, 90, the two sides have to be the same, right? Okay, so this would be 1, and I'm just going to count to 2. Cool? And when I stop counting, I'm going to give it a radical. So I've got 1, 1, 2, because those have to be the same. And I stop counting to 2, so I get the radical, it goes there. And then the other one, I've got 60. Let's do it the other way. Let's do it the other way. Let's do 30, 60, 90. Okay? So I'm going to go 1, 2, 3, and then radical.
Wait.
Use what you can. It works for me, and I know what's happening to my cabeza.
Is that the 3, 4, 5 one?
No, that's a 1, 2, 3, 1, 2 radical 3.
Why is
If it was a 3, 4, 5, the 2 legs, that means the 2 touching here, would have a 3 and a 4, making the hypotenuse 5. Okay?
Do they have common angles? 3, 4, 5?
What do you mean common angles?
Like, you know how that's a 30, 60, 90? Like, if it
I don't know. I don't think they're nice. I can try to find out for you real quick.
One of them.
Let's see here. It's not nice. It's not nice. It's like 64 point something. Okay? All right. Let's move on, because I want to try to get through this today. So I've got some stuff to do. Okay. Here we go. A right triangle with 45 degrees, aka pi/4 radians, is isosceles. That is, it has 2 sides of equal length.
Okay, so we have 9.9.
So draw it. Draw the triangle. Which is a special triangle? What's it going to look like?
4, 5, 4, 5, 9.
And the sides are?
Equal.
Yeah, so what are all the sides, I guess I should say?
X, Y,
Yeah, you could do that, because it doesn't give you length, does it? But you should go with the 1, 1 radical 2. Okay? So it should look like this. Okay? And I should have, we'll just use the basic ones, because these are the sides that we always use, actually. Technically, 1, 1 radical 2. But you were correct. They would measure x radical 2. Okay? Questions on that? What's that? It was an isosceles triangle. So, what's the image they give you? Oh yeah, no, it is, because these 2 sides are the same. If I were to, yeah, I'm trying to, if I did that, it's isosceles. 2 sides are the same. Okay? That's your question? Right, right. That's where that came from. How do you draw for me the 30 degree, the 30, 60, 90? Draw for me the 30, 60, 90 real quick.
Oh, I got it.
get slapped. Don't get backhanded. You could have drawn this a couple of any different ways. It really doesn't matter to me. It doesn't even have to look right, as long as you got the sides the way it's supposed to be.
60 opposite is radical 30, and then 30 opposite
Mr. Julio,
What's up?
wouldn't the 60 be where the 30 is?
Opposite to 30 is always going to be the 1. No matter what.
So it doesn't matter what, like where the 60's at.
As long as you put the 1 across from 30,
That's it. So it doesn't matter.
and then the 2 should be the hypotenuse. It should be the biggest side, right? So then that's the leftover one. Okay? Like I said, there's a bunch of ways you could have drawn your triangle. You should be good. As long as you put the 1 opposite to 30, and the biggest number you put with the biggest. Oh, that's also another rule you could use too. Just thought about that. Makes sense. The biggest number goes opposite to the biggest side, the smallest number goes opposite to the smallest side, and the leftover one goes where you don't have something. Alright, ready?
Yeah.
Let's do this.
Yeah.
Here they want us to find cosecant 45 and secant 45. So, obviously, because I do have a 45, that means I'm using a 45, 45, 90. 1, 1, radical 2. Cosecant of 45 is hypotenuse over opposite.
Yes.
It's hypotenuse over opposite. Therefore, I've got radical 2 over 1, which is simply radical 2. That's my phone catching up. In here, it'll get a signal eventually. And then once it does, everything comes through. So what you hear is like, ding, 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 ding. No, I don't know how to turn off notifications on something.
I know how to turn them on.
No, it's from a weird app. But yeah, my wife will text me. Little X's and O's and little winky faces.
What is that?
So the
That's cute. That's what that is.
The secant is
Secant is the reciprocal of cosine.
so that's H over.
So it's going to be H over A, right?
Yeah.
Which, guess what? It's the same thing.
Okay.
Cool?
Okay, we're good.
Hold on. Oh, never mind.
We okay? Yeah? Yeah? He was like, oh my gosh. Greg, you okay? You want to go to the nurse? You want to go to the nurse, Greg? Well, then that's not good. I would hate to be sent somewhere when I'm sick and... Buy me tan 60. Buy me tan 60,
Can
please.
you leave it alone for like 2 minutes?
Oh, for sure. I can leave it alone.
Yeah.
For sure.
So the 16 is to 16. Tangent, which is opposite of adjacent, so the opposite will be adjacent. Opposite, which is 3.
Okay, so where'd it go?
The opposite of the 60.
I don't know.
I mean, the way he's doing it is the same thing.
Okay, so there's my 30, 60, 90, right?
Yeah.
And I want tangent, so I'm from here, tangent of 60. So I want the opposite
He's gonna get the same thing.
over the adjacent, which is radical 3 over 1, which is just radical 3. Okay? All right. Now, I would not recommend you write this down. I don't want this to be a crutch. Okay? If you want to take a picture to have it there, like, hey, that's my background. Cool. But you should be able to draw these and then produce all of these. I would recommend you do that instead. So always draw the triangle. It's just good practice. Here are the ones for secant. Oh no, I don't have them. Okay, maybe I have them. No, I don't. I guess not. Let's continue. Do you guys remember when I first, was it last Monday or Tuesday? No, it was Tuesday. Yeah. When I said, oh, the sine of something is also equivalent to the cosine of something else?
Yeah.
Okay? And that's what we're talking about with this slide. It's a lot of mumbo jumbo, but here's what you need to know. Let's say I had, let's do the 30, 60, 90. Is that cool?
Yeah.
Just because there's a 90. Oh, no. So let's do 60 degrees here. Let's do 30 degrees here. Okay? That means this is a 1, 2, radical 3, right? And if I were to find the sine of 30 degrees, what's the sine of 30 degrees? So opposite to 30 is 1. Hypotenuse is, that's 1/2, correct? Find me the cosine for 30 degrees. Cosine is the, hold on. Laptop. Laptops. Please let me have your attention up here, because if you miss some of this, you're going to hurt later. What is cosine 30?
So radical 3 over 2.
Oh, wait a minute. That's not what I wanted to do. I want to do cosine 60. My bad. I apologize. What's cosine 60? 1/2. See how they're both, sine 30 and cosine 60 have the same ratio? That's the point that this slide's trying to make. So if you're trying to find a complement of something, for example, the complement, let's say I had sine, someone give me a weird integer between 0 and 90. 12. I heard sine 12 first. That would be equivalent to the cosine of, what's 90 minus 12? 78. Those two would be equivalent. And that's what this is saying. Okay?
Is that the same for like
That's the same for cosecant with secant and
tangent with cotangent.
tangent with cotangent, I believe. I could be wrong.
wait, can you go back? Or is that the same thing on the
Yeah, I was going to give you the whole list here. So here's your equivalents. So sine with cosine, tangent with cotangent, secant with cosecant. Okay? So, yeah, no, not the same angle. They'll have the same ratio. Obviously, they're not the same angle, right? Because 12 degrees is not 78 degrees. But the ratio is. See how over here, when I did sine 30, here's 30, correct? It's 1 over 2. And the cosine of 60 is also 1 over 2. So what I'm saying is the ratio of the complements is the same, not the angles. Yes. That's the point I was trying to make. That you'll have, every angle can have a complement. And what you got to make sure is that these two make 90. In order for them to complement, yeah. Correct. And here's your matched pairs right here. Sine and cosine complement each other. Tangent and cotangent complement each other. Secant and cosecant complement each other. Yes. That's why I put those there. Those are all your complements right there.
I noticed it yesterday.
Did I miss a word here? I feel like I missed a word. I did.
What did you miss?
Besides complement, I think it's here. They're also called
Co-functions.
cofunctions. You're gonna have to memorize which are cofunctions, okay?
Okay.
AKA complements.
So
Alright,
those things
are we good?
right there?
Yeah, it's those things. Those are
Okay,
cofunctions. Okay?
I can remember. I can memorize.
Cofunctions.
Are they complements? It's like complements.
I have Yo Royal Knight watching us.
Anise is watching this.
And Anise says I like that better. What do you like better, Anise?
Anise just.
I just saw that right now.
I know,
My bad.
She's texting me. She's like, "Teacher, I can hear you." And I'm like,
Hello.
Hi,
She's
niece.
actually like watching.
Cool, I'm glad she is.
I was sick and you guys said hi to me.
Leave your likes and subscribe. Now she should be saying it right now. Alright, I can change the slide?
Yeah.
Alright, cool. I'm gonna move it on. Anise, something else you can do if you miss something, you can rewind and it'll keep playing from there until the end, which is kind of cool. Alright, so again, what's the cofunction for sine 46?
The cofunction.
What's the cofunction of sine?
Cosine.
Cosine. And the angle should be
44. No, it'll be 44.
44, right? So these two should be equal. The ratio of those should be equal. Okay? This is so difficult.
It's actually not.
It's not. That's why I love Triggy.
It's not difficult. It's just.
difficult to see colors and signs and stuff like that. I'm like, with
Well, I would write sign like that all the time. I had a kid that could never get past calling it sin.
Oh yeah.
Calling it sin.
I called it sin freshman year just because it annoyed Miss Hawkins.
Because it's sign. It's really sign. I can change it? You guys okay with cofunction?
Yeah.
Wait.
So co-functions are just complements?
Oh, it must have been bad. The first one says hi everybody, and the other one was show says it was held for review. Make sure to like and subscribe. Thank you. All right, guys, here we go. Oh,
Wow.
what is the cofunction for this?
It'll be tangent.
Tangent.
Okay, so everyone agree it's tan?
Yeah.
Cool. What's the other part though?
Oh, it's 1/2 pi. Right? 1/2 pi minus pi over 4.
Yeah.
Okay. Stop and think about this real quick. Because it's in 12ths, how many degrees how many degrees is each one? It's what? They're 30s. But Birch, remember that they have to be from
It's 360 degrees.
from 90, right?
Yeah.
So if I have, let's see here. Here's
Pi over 3.
12 twelfths, right? No, that's 6 twelfths, because it's pi by itself, right? So this should be 12 twelfths, right? So that means I've got 1/12. I should have how many total in here? How many 12ths?
6.
I should have 6 12ths.
What?
Wait, why does it
3.
Hold on, is that 30s then? No, this is wrong.
Oh, I thought it was 30.
Because it's, you know what, let's just do this. I have pi 12ths plus something, and together they should make pi halves. I'm just going to algebra this. I'm going to ask my good friend algebra.
I like algebra.
So I'm going to take away pi 12ths to both sides. That's gone. I need a common denominator, which is
It's gonna be
12. So this becomes 6 pi? So 6 take 1 away gives me 5 pi. Okay, sorry, 5 pi 12ths. So there it is. So tangent of 5 pi 12ths. Okay.
I'd rather do the circle.
Yeah, I would rather do circle. So if we're here, like I said, we have, this should be 12 12ths, right?
Yeah.
Which means this would be 6 12ths.
Yes.
And if I got one of them for this pi 12ths, then how many more do I need to get to 6? 5 pi 12ths. And that's where it is again. Okay, so just remember, you're breaking up into pieces, little fractions, but you do have to remember that they're complements. So you got to stick within that pi halves range. It's got to be in that 90-degree range. Okay? Anybody still writing here? Yes. A couple of different ways of looking at it. Okay? And if you're the person, I have to confess, when I was in high school, radians made no sense to me.
I mean, they make sense.
Degrees, I could do degrees all day, and I knew my conversion. So no matter what, I always went from radians to degrees. I manipulated my whatever I needed to do, and then I converted it back to radians. And that worked for me. And that's totally okay.
We're not best friends.
Wait.
We're just like acquaintances.
So that's not 30 degrees then.
It's 15.
Or 15 degrees.
So 5 pi 12.
6, if denominator 6 is 30 degrees. Denominator of 6 is 30 degrees. So these are 15 degree angles.
So
So it's all 180. It's not just easy, it's all 180.
Well, remember pi is over here, right? If 360 would be 2 pi's. Right?
Yeah.
That's what is throwing me off right now too. I can change slide now?
Yes.
All right, let's talk about some of my favorite problems. Some of my favorite problems. Oh, where'd you go?
Oh,
2
those
words you need to know.
problems? I like those problems.
Angle of elevation,
Angle of depression?
angle of depression.
Yo, I'm depressed. That's okay. I know the depression one.
And you know what? I actually used to use that to remind me when you're depressed, your head's always down.
it wasn't.
I keep my head up high. So depression would be down. Elevation would be up. Okay?
What?
Elevation is going up. Depression is going down.
Yeah, because we're gonna depression.
It's really just vocab. Elevation means your angle is going up. Depression, it means the angle is going down. Okay?
You're depressed, pretty sad.
Cool. Now here's actually what some of your what do they call them? Surveyors do?
Survey.
The people that measure land? They measure your land.
Oh, yeah.
They survey land. They actually do trig.
Oh, yeah. Yeah,
They go
have
on, they
to.
put a post somewhere, and they got their little, I don't know what it is, I want to look through one though.
Oh, those little angle things?
Yeah, and then they do this measurement stuff, and they're like, okay, that's where you should go. And then they'll mark your point, and then they'll go over there and mark it and make sure it's correct. Mark it correct, and then say, here's your boundaries, which is really, really cool. So anyways, the irregular shape of the figure represents a lake. So that blue blob is supposed to be a lake. The distance across the lake, they're saying from bottom all the way to the top, they don't know what it is. And obviously they can't take a tape measure, right? And go around it. Here, you take this end. I don't know why they can't, but to find the distance, the surveyor did some measurements. He got on one end, and he walked away. He walked away 750 yards.
Jeez.
He has a stake up here, and he has a stake there. And he's going to measure that angle between the two, so he knows what the length of the lake is going to be, or the height, or whatever you want to call it.
Yeah.
And they're going to use some trig, which is your problem right here. Okay. So here's what we have in this situation. Okay. So let's ask this question: which am I looking for? Which side am I looking for? I'm looking for A, correct? So now, I'm looking for A. Technically I have B, don't I? I have little b.
Yeah.
Okay? So I want A and I have little b. Which trig function are those two compared to my view side of 24? I have the opposite and I have the adjacent, don't I? So what is that? That's tangent, right? So I'm going to search for tangent of 24 degrees. Now that should equal the ratio, correct?
Correct.
And the ratio is opposite over adjacent?
Yeah.
The opposite is A, the adjacent is 750, correct? We're solving it for A. And we're just going to use some good old algebra here. How do I'm dividing A by 750. I'm going to multiply by 750, okay? So 750, why did I put degrees? I don't know. I just thought of it right now. So 750 multiplied by the tangent of 24 is the value of A. Now, 24 degrees, so make sure your calculators are in degree mode.
It's in radian. So then you would do 750 times 15.
I'm in radian mode, so I'm going to have to switch over to degree mode.
334.
Yeah, 334.
And then like yards.
Yeah, it'd be yards, but because he just did it. And but would you round it up?
Yeah, so depending on what your problem says, you're going to either round up or not.
Why did you say tangent 24 equal to A over C?
Okay, go ahead.
Tangent is
Why did you set tangent at 24 degrees?
What's the definition of tangent? Okay, so I'm going to go over to my viewpoint. I'm the observer here, right? This is me. And I know my angle, so here's where I'm standing. And tangent, what'd you say it
I
was?
read it wrong.
You're good? Just to finish answering that question, I'm here. I want the opposite. I have the adjacent. Opposite adjacent is tangent. Now, what else could I have done? Could I have done cotangent? Yeah, I could have. But why?
yeah,
But you'll get the same thing.
yeah, because you would have kind of.
But you'll have more math to do.
Why do not like cotangent?
Because you'll have to multiply and then divide versus just multiplying. Does anybody want to see it that way?
Okay, so like let's say that it would be easier to do it that way. Like,
Go ahead.
the opposite, like let's say like 750 was where A is and A is right there. Could you use like the inverse to make it easier?
Yes. You can use the cofunction. Or you can use, yeah, it just depends what you want to do. But yeah, sometimes you'll play around, you say, oh, it's easier to do this than it is to do that. Definitely. Cotangent here would be harder. And this is why. For those people that didn't ask, I'm telling you anyway. If I did do cotangent 24, I would get 750 over A, wouldn't I?
Yeah,
Sorry. And then here's what I would have to do. Multiply both sides by A,
and then
and then I would have to go and divide both sides by cotangent of 24. Cotangent of 24.
and that would just be like.
So if you did 750 divided by the cotangent of 24, you should get your 333.92 again. Okay? It's totally up to you. So, with that, let's do your problem real quick. Are we good here? So the problem that you posed at the beginning was, here's C, this is 35, and I've got 29 degrees here, right? So my viewpoint, where I want to look at this from, is from 29. I have the opposite, I want the hypotenuse. Opposite hypotenuse. Which trig function uses that? Sine. So I'm going to take the sine of 29, that is 35 over C. You see what happened? So that's the same scenario as before. I'm going to multiply both sides by C. This is gone. Stop stretching. So I've got C times the sine of 29 degrees is equal to 35. And then I'm going to divide both sides by sine of 29 degrees. Sine 29, sine 29 is C. And then I'm going to take my calculator. I'm going to do 35 divided by the, what was it? Sine of 29. Am I in degrees? Snap, I'm not. I just don't want to type it again, so I'm going to do this. I'm going to go mode, degree, so I can quit. And if I do enter again, it should give it to me with degrees. So there it is. So that's the length of C right there. 72.19. It's not very nice. Okay? Cool? Other questions? Any questions from? Go ahead. whichever angle you're looking at. So it depends on how you drew it too. So in this case, here's my 29. That's what I know. I could have done it there. But, so let me give you a bunch of, since we have time, right? Not really? That's okay. I'm going to take the time. There's a couple things you can do. Let's say you didn't like this for some reason. I know that if this is 29, what's this angle up here?
61. Yeah, 61.
And, oh, sorry, I don't know why I did that. And I don't want to have, and I don't want this hypotenuse to be in the numerator.
Yeah.
I could also do, sorry, I lost it there. Instead of doing the sine of 29, I could have also done the cofunction, which was the cosine of 61. And that would also give it to me as well. Right. But there's a bunch of different ways you could have gone. Or I could have done the sine of 29, which would be the same as the cosine of 61, which is also equal to I could have also done the cosecant of 29.
Yeah.
I could have done the cosecant of 29, and I could have done the secant of 61. Any one of those would have done it for me. Any one of those would have done it for me. Okay?
Yeah, because cosecant is
So I really have 4 options. And whichever one you see first, go for it. Okay? Alright, cool. Everyone say bye to your niece.
Thanks for coming in.
Toast.